Welcome to Ecorptrainings. We are providing IBM WebSphere DATAPOWER SOA appliances online training, corporate training or classroom training from Hyderabad, India. Today we are going to discuss few points about software architecture of DATAPOWER SOA appliances. Software architecture of appliances. In DATAPOWER SOA appliances, customized, hardened, native code operating system kernel that implements the appliance's core functionality. The operating system resides in firmware that can be updated by applying small firmware update files. On top of this layer is a functionality implemented in XSLT which are read-only and used by the system. The next layer is the configurations developed by the user. These are application proxies, processing policies. All appliance implementation are custom and proprietary, but on a single foundation XML. DATAPOWER SOA appliances administrative model. All remote administrative interfaces are shut down by default. Here, Command Shell Admin can be accessed using Telnet, Secure Shell, or the serial port. In ultra-secure environment, where all the remote administrative interfaces are disabled. Coming to DATAPOWER SOA appliances, XML management interface is used to obtain status information via XML-based SOAP requests. Specifications like SOAP configuration management and WSDM. DATAPOWER SOA appliances is Web GUI admin console have browser-based administrative interface. Well laid out, attractive and intuitive. And enabled only in development environment. Programming model of DATAPOWER SOA appliances have some interesting points like user-friendly drag and drop features of the processing policy editor. XML-centric, XSLT used as the programming model for customized programming. XPath expression are used in building configuration is the Web GUI. All the power of XML, SOAP, and many of the WS specifications standards are available on the appliance. How does DATAPOWER SOA appliances fit into the network architecture? C. DATAPOWER has a set of 4 network interface jacks on the front of the appliance labeled MGMT, Ethernet 0, Ethernet 1, and Ethernet 2. Management port and the ports split up to the administrative subnet, and remaining 2 ports receive client traffic, and the other connects to the back-end server. A number of network protocols supported on the appliance: HTTP, HTTPS, FTP, FTPS, SFTP, NFS, MQ, JMS etc. Monitoring can be achieved by SNMP, MIB files, which can be imported onto monitoring tools. Configuring network interfaces settings are: go to network, from there to interface, and there you got Ethernet interface. Ethernet interface changes require admin access. Clicking on a particular interface, say Ethernet 1, it opens the configuration screen for the same. Fields like IP address in CIDR format, use of dynamic host configuration protocol like DHCP etc. needs to be filled to get the interface configured. Coming to DATAPOWER static routes. Network devices maintain an in-memory table of rules that are used to decide how to send traffic to other nodes. These rules are called routes. Many routes are generated dynamically based on the configuration of interfaces, but sometimes there is a need to explicitly add a static entry. Configuration of such rules are entered beforehand. If you do need to add a static route, click the Add button. On the screen that appears, type in the destination with subnet mask, either in CIDR format or as dotted quads separated by a space. Also supply the gateway for each static route for this interface. Here we need to know some other network settings. Those are: General Network Settings. Go to Network, there you find Interface, Form, there to Network Settings. Settings are advanced and would not require any changes. These are global settings which affect all the network interfaces. DNS setting. The domain name service is a way of resolving host names to IP addresses, or vice versa. It is possible to configure the DataPower appliance to utilize one or more DNS servers. If you choose to configure a DNS server, select Network. Here you find DNS Settings from the navigation bar on the left side. Doing so brings up the screen shown in. DNS configuration consists of domain stems, which are automatically added to the search if you search by a hostname, along with DNS server configuration and static hosts information. There is one more important option on the DNS settings page, located on the right side of each tab, the Flush DNS Cache option, as shown here. Like the vast majority of DNS clients, the DataPower appliance will cache DNS responses locally, and, if it needs to look up the same hostname again, it will retrieve it from cache rather than contacting the DNS server again, if the entry on the server has been updated. This can be done by clicking Flush DNS Cache. DataPower SOA appliances can provide a lot of information about the status of the network configuration. This information can be invaluable in debugging network issues. This section lists the key tools available to examine the internal workings of the IP stack. If you click on Status, there you find Ethernet interfaces. You can see information about the way that the interfaces have been configured. As here shows, it is possible at a glance to see which interfaces are physically connected, what negotiation mode and speed they have used, IP addresses configured, hardware addresses, received and sent bytes and packets, and so on. One of the chief uses for the interface status page is to debug network errors. Collisions of packets on the network or even packets being dropped can have a serious effect on the function of the device. This behavior may be related to, for instance, a failure to correctly negotiate network speed, as described earlier about routing table. Network devices such as the DataPower appliance maintain an in-memory routing table, a list of rules that define how packets should be sent based on the destination addresses. The device's routing table can be displayed by clicking Status. There you find Routing Table, as shown here. The information in the routing table includes any specific routes that relate to a given interface, any default routes that have been configured, and any static routes that have been added. Coming to TCP Port Status. Possibly the most often used network status screen is the TCP Port Status. This is the equivalent of a netstat on a distributed platform. It lists the TCP sockets on a given device, what state they are in, what the source and destination addresses and ports are, and so on. Finally, ARP Table. ARP full form is Address Resolution Protocol. ARP Table resolves IP addresses to physical Ethernet addresses. It contains the hardware addresses of all the nodes with which the appliance communicates. For more details, please visit www.ecorptrainings.com. Ecorptrainings contact details. For USA, +1 7034454802. For UK, +44 203 468 0685. And, for India, +91 814 311 1555. Email us at training@ecorptrainings.com. Thank you.